Hi everyone. This is a quick explanation of question number 9 from our revision sheet for maths methods. So we've got that tower A, the diagram is part of my solution. The question is completely in these words here. So we have here that the tower A is 4 kilometres due west of tower B. So I started drawing my diagram. I put tower A at the origin of the XY coordinate system, and if that's to the west, it means B is to the east by 4 kilometres, so I just located this at point 40. There are flagpoles at C and D. The bearing of C from A is 025 degrees true. So point A, I have to imagine myself standing at point A. Due north would be looking up the y-axis, and 25 degrees true means 25 degrees towards the east, so this angle is 25. That gives me a 65 degree angle down here compared to the x-axis. That's the important one because that's the internal angle of a triangle. It says the bearing of tower, and then I just draw a line running off in that direction into the distance. Now the bearing of C from tower B is 350 degrees true. So here's point B. I imagine looking due north. I don't quite know why my pointer has gone away there. Nope, still not a pointer. Oh, still not, it doesn't matter. So point B is there. True north is straight up this vertical line. 350 degrees is true, is all the way around to east is 90, south is 180, west is 270, and then a further 80 degrees here would get me to 350. Alternately, you could think of this small angle as 10 degrees, leaving 80 degrees as the internal angle of a triangle. Then I draw a ray along that line, and where those two lines intersect is tower C. Now my immediate job is to find the coordinates of tower C, the x and the y coordinate, these red lines here. Now to begin with, I will start thinking of triangle ABC, and I'll use the sine rule because I know two angles. I know angle A, I don't know side A. I know angle B, but I don't know side B. I do know this edge, which is edge C, opposite. So I suppose the first thing I'll do is think about what angle would be up there. If you subtract 80 from 180, you get 100. If you subtract 65 from 100, you're left with 35 degrees. So now I can use the sine rule. I can go, and I might try to find edge B here. I could go B over the sine at angle B equals C, which is the edge I do know, over the sine of angle C. So B therefore would be the sine of angle B is 80 degrees, C is 4 kilometres over sine 35. And that gives me that edge B is 6.8. Now it's a messy number, 6.8, working in kilometres. The next thing is to look, I've labelled this point here point E, so I have a right triangle. I'll be looking at triangle AEC. Now, because it's a right angle here, I can use sine and cosine, SOHCAHTOA. So the sine of 65 degrees would be the y coordinate divided by b. So that's the y coordinate of point C, and b was this 6.868 kilometres. Now, a little bit of working later. I'm trying to save a bit of time here, so I won't show every last step. A little bit of working later, we get that the y coordinate is 6.224 kilometres. What did I write? Y there. Kilometres. Now the cosine of that 65-degree angle would be the x-coordinate divided by the hypotenuse, 6.868 kilometres. And again, a little bit of working shows me that the x-coordinate is 2.903 kilometres. And that's all to do, the whole diagram and working is all to do with that clue there about the location of tower C in comparison to A and B. Then I have a different clue about a different tower D, which has also been given locations compared to point A and point B. This time it's 35 degrees true from A, and it's 345 degrees true from B. So this needs a fresh diagram. It'd be too messy. This one was 45 degrees here, leaving 55, and this one was 345 degrees true, meaning 75. So this new point D, so A and B are the same, 4 kilometres apart. I am going to have exactly the same working. I'll be using the angle here at the top. Now the angle at the top this time is going to be a little bit larger. That one works out to be 50 degrees when you subtract 55 and 75 from 180. And then we'll use the sine rule again. And eventually we will get, so I'm just going to save a bit of time here. I'm going to go similarly, because the working for this one is identical to the working back there. Now I'd encourage you to write it all down, but this time I get that the x-coordinate of point D, so there's tower D, that one is 2.893 kilometres, and the y-coordinate of point D is 4.132 kilometres. Again, to save time, I'm not showing all the working, but the working for that one is identical to the working for this one. You would need the sine rule first to find the length of edge B. Now, even though I've called them A and B, it's a different triangle, they'll be different lengths, so don't just reuse the same length B from earlier. And then XD and YD would come from SOHCAHTOA of this right angle triangle. But importantly, I now have on my Cartesian coordinates the location of point C and point D. And the question wants us to find the distance between point C and point D. So here I go. There is a neater version of the diagram. I still have point A, I still have point B, 4 kilometres apart. But really, these two don't come into it anymore. I've got the location on the coordinate grid of point C and point D. And if I want to find the distance between 2 points, I use the distance formula. So remember, it's x2 take x1 squared plus y2 take y1 squared, and then we take the square root of all of that. Now, you might note that the x-coordinate of C and D is almost the same. In fact, if I wasn't working to 3 decimal places, I might have accidentally gone 2.9, 2.9, and then I would think that it was just a vertical line between these two. So it's always worth using a few more decimals, although to a first approximation, it will be very close to a vertical line, which means our answer will be very close to 6.2 subtract 4.1. But if we want to do a good job, we should work to a few more decimals, and they're not exactly the same, which means we do need the distance formula. And so substituting in here, I'll go 2.903 subtract 2.893 squared, and then keeping the same one, 6.224 minus 4.132 squared, all with a giant square root sign. And when I did that, I got 2.093 kilometres. And that's the distance between the two of them. Okay, that's that for that one. Thanks for watching.